Okay, so we're going to be looking at angles of elevation and depression today. So an angle of elevation is the angle through which your eye or head moves to look up at something. Okay, so that means that you're situated down the bottom, you're going to be looking at the object that's up the top here. So your normal eyesight would be straight ahead. Okay, to look up at something, you need to focus your line of sight on that object. So your eye or your head needs to move through this angle to be focusing on that object. All right, so that is where the angle is that your eye or your head has to move through to be focusing on that object. So that theta that we just wrote in is the angle of elevation. So remember that elevation is up, looking up at something. Okay, so the opposite one is angle of depression. It's the angle through which your eye or head moves to look down at an object. So in this situation, we're up the top here. The object is down here. So depression, down. So we're looking down at something. But your normal eyesight, if you're up here, would be out there somewhere, straight ahead. Okay, so you need to turn your eye or your head through an angle so that you're focusing on that object. So this is the angle that your eye or your head has to move through to be focusing your line of sight on that object. So that theta that we just marked in is the angle of depression. Now, there is a connection between the angle of elevation and the angle of depression. So if you look down here at this diagram, if I put the angle of elevation in, it would be me here looking up, and this would be the angle of elevation. Actually, I'll put an E there for elevation so you can see what I'm doing. Okay, now if it was the other way around and I was up here and I was looking at an object down there, I would have to draw this line out here because my angle to turn my head has to move from straight ahead down at the object. Okay, and that would be the angle of depression. Okay, so the angle of elevation equals the angle of depression. Now, why is that? If you think about it, you've got two horizontal lines here, and if we draw arrows on them, the horizontal lines are parallel lines. So what we've got here is two parallel lines and a transversal going through. So we have an angle here and an angle here. So we've got alternate angles. We're forming a Z shape. So we have alternate angles forming with the angle of elevation and the angle of depression. And alternate angles are equal in parallel lines. So that's why they're equal. All right, now, to do the questions on this, the first two are just pretty easy. We're marking the angle of elevation as theta and then finding its size. So in this one, if you're looking up for elevation, looking up at something, that means you're down here. So the angle of elevation would be here. And we have to find that angle. Now, if you look at your triangle, there's 180 degrees in that triangle. 90 degrees is taken up with the right angle. So these two must add up to 90 degrees. So the easiest way is to just do 90, take away the 70, and you'll get 20 degrees for that angle of elevation that we just marked in. So in the next one, they want us to mark in the angle of depression and then find its size. So if we're depressed, we're looking down here at the object down the bottom. So the angle of depression is from our normal line of sight to focusing on our object. We've been asked to put a theta in there for the angle of depression, and now we're going to find that angle. Now, these two angles here make up a right angle because you've got a vertical line and a horizontal line, so there's a right angle between them. So to get that angle there, we're just going to take it off 90, and that will leave us with 49 degrees for theta. Okay, let's look at some word problems now, which is what you're normally going to be getting in exams. All right, so number 3. We have a 275 metre tower. It's 1.8 kilometres from a school. All right, so we're going to draw up our right angle triangle. The tower is the vertical line. It's 275 metres tall. 1.8 kilometres from a school. So here's your school. And the bottom of the tower is 1.8 kilometres from the school. All right, now the question says, find the angle of elevation. So we need to know how to mark that in. So remember, we're looking at the angle of elevation of the top of the tower, which is up the top here. That's the top of the tower. So we're down here at the school. Normal line's eyesight is straight across. We want to be focusing on the top of the tower. So our angle of elevation is in here. And we'll just call it theta for what we're doing. All right. So now we're going to just label our sides like we normally do. These two that we have numbers on. So we have an opposite side and an adjacent side. So that means we're dealing with tan. So we start with our formula. Tan theta equals O over A. Now we're doing tan theta equals, now the opposite side is 275 metres. Now you'll notice the other side is in kilometres, so we're going to convert that to metres because everything has to be in the same units. So if we go to metres, we're going to a smaller unit. So we times, kilo is 1,000, so times by 1,000 and you'll get 1,800 metres. So we're going to be using that one and this one. They're both in metres then. Okay, we don't really need the units. I'll cross those off. So now we're going to get we're going to get theta by itself. So we're going to get rid of that tan. So go to the other side with that and do the opposite operation, which is tan to the -1, which is inverse tan. Put your fraction down in brackets, and then we go to our calculator. So you can press this in yourself now. Do shift tan, fraction 275 over 1800, right arrow out of it and close the bracket, press equals. You will end up with what I've got there. The question wants us to do this to the nearest degree. My answer is in degrees because that's what the D on the top of the calculator is for. It's telling you your answers are in degrees. So now, nearest whole number. Okay, that's 5 or more there. So we're going to go up by 1, and our answer is 9 degrees. All right, the next question over here. Start with your right angle triangle. In a hall, Ben is sitting 18 metres from the stage by line of sight. He is also 4.9 metres above the level of the stage. So Ben is up here. He's looking at the stage, which is here. All right, so he's 18 metres from the stage by line of sight. So in other words, while he's looking at the stage, that's 18 metres there. He's 4.9 metres above the stage, so that's this bit here. And they want you to find the angle of depression. All right, so angle of depression means we're looking down. So we are where Ben is. Okay, he's looking down at the stage. So he would normally be looking straight out. He's focusing down at the stage. So we're trying to find that angle there. All right, now to find that angle there, you've got to remember what we said before about the angle of elevation and angle of depression equaling each other. Okay, so I don't really want to find that at the moment because it's not inside the triangle, but I can find this angle down here. I'm just going to use another colour. I'm going to find this angle here. And remember, they're going to be the same. So if I can find this, then I'll have my angle of depression worked out anyway. All right, so let's find the blue theta. I'll just write it in here so you know what I'm actually looking for. All right, so in the triangle, let's label the sides. We've got opposite and we have hypotenuse. That means we're dealing with sine. So write your rule down. Sine theta equals O over H. Let's sub in. Sine theta equals 4.9 over 18. They're both in metres, so that's good. Get the theta by itself. So we're getting rid of sine. go to the other side and do inverse sine. And make sure you put your fraction down. Put all of that in your calculator, shift sign, fraction key, 4.9 over 18, right arrow, close the bracket, equals, it'll give you that answer there. Now we're rounding in this one to the nearest minute. So we're going to just rule a line after the minutes and look at all those seconds over there. We've got 30 or more seconds, so we're going to go up by 1 in the minutes to 48. And our answer is 15 degrees, 48 minutes. So I'm coming back in the next video to do a few more examples.